Hello, this is Laura Wogezogen, your math instructor for Honors Statistics. This is the second video for Project 3. And so for this point right now in the project, you should have an idea, you should have a hypothesis, and you should also have your introduction paragraph done. So the next part that we're diving into is all the statistics. So we are going to be looking at the statistics and the calculations. And so you'll see that in your module. There'll be a handout here. They will also be available outside of my office, so you can always grab these handouts too if you'd prefer to have a paper copy. And so with this, you're going to be looking at StatDisk and using StatDisk to come up with your confidence intervals, test for normality, and your additional hypothesis test. And so you're going to turn in a typed PDF file with all the StatDisk screenshots that include all of the following information. So this is pretty much the calculation part of it. This is going to allow me to give you feedback if you're missing anything or if something doesn't seem correct. That way you have time to go back and re-edit, and then also again come by, stop, ask if you have questions. So the first thing that we have on here is confidence intervals for both of your sets of data. So again, like I was talking about doing the foot length and height, I would have to come up with the confidence interval for the mean foot length and the mean height. And so I would do each of those separately. You also need to make sure you check for any constraints. This will be for each of your data sets. So since I'm dealing with the mean, I have to have a sample size that is greater than or equal to 30. I also have to have it be a simple random sample. So I need to make sure I check those constraints and verify them. If you're doing proportions, those have different constraints, so make sure you look back at your Chapter 7 notes. The second thing that we have is going to be your test for normality. And so for the test for normality, this is in section 6.5. If you go back in section 6.5, you will notice that there's 3 things that you need to check. It should be the very last example in those notes. And it says you need to do this for both sets of data. So you're going to have to check those 3 requirements for the test for normality for both sets of data. So again, for me, it would be the length of your foot and then also the height. The third thing that we have on here is that additional hypothesis test. And so with this, it is going to be unique for your project. And so it says, depending on the type of variables that you are going to be using and exploring, you should only pick one of these to use. And I was saying that mine was coming from Chapter 10, which is the linear correlation, because I was assuming, or my hypothesis was that as your height increases, your foot length is also going to increase. And so that would be mine, but maybe yours is a test for 2 means independent samples, like we were talking about rainfall in Yosemite and rainfall in Sequoia. Maybe I think that they are not the same. So whatever it is, I would have to write down my H0 and H1, so both of those hypotheses. And I also need to check those constraints. So make sure you go back and look at those sections to see what constraints need to be checked in order to perform that test, what requirements need to be met. And then you need to go through the test using StatDisk. And so using StatDisk, then you need to have that. You need to compare your p-value to alpha if you're using the p-value method. And then state if you're going to reject or fail to reject your null hypothesis. And then also make sure to write a conclusion. I know that we are very statistical based right now, but I want you guys to also think about how you would word it so that it makes sense to somebody who's reading this, maybe somebody who is younger, maybe someone who's only 8 years old and that doesn't have a statistical background. So you want to make sure that you can explain it in a way that's understandable to all readers. And so at the bottom it says, make sure to verify that the test can be performed and show all of your work, state the null and alternative hypotheses, run the test using StatDisk. You need to make sure that you have your screenshot attached or put into the upload. And then you're going to conduct your test either using the p-value method or the traditional method. And then make sure you state your conclusion. So this is the next part. This is the meat of the project. So this is the part where most of your points are going to be coming from. And you'll notice too on here there will be an upload spot to upload this, so make sure you read that. And in addition to this, I did post a checklist. And so the checklist is just going to be just a brief outline of everything to make sure that you have what you need. So on here, check off what you have or what you're missing. If you have questions about something, you can always ask. So again, your introduction at this point should be complete. Don't forget to include your data. I do need to see that. Or if it's a very large data set, maybe it's a link to the data set on the website. You have your confidence intervals, test for normality, and a hypothesis test is all listed here on what you need. Don't forget that once you're done with all of this, everything should be done and you should be ready to write your conclusion, which is stated here. And then make sure that you also state if you used any outside sources for your data. So if you did get your data, let's say from the National Park website, make sure you list that, or a ESPN or one of those other websites. So again, I listed the excellent category here for the rubric, but you can always look at it again on Canvas. So again, any questions, definitely reach out. Come by office hours is the best suggestion that I have. If you're looking for a place to work where you can use StatDisk, it is online, you can use it anywhere, but the Marks does have an instructor that knows StatDisk and can also help. Best of luck.